and welcome everyone. Thank you so much for coming here at the end of the presentation, at the end of the day. Hopefully you're still awake to see our practical journey with Spring GraphQL. So let's get started, because we've got like ground to cover. So my name is Frederieke Scheper. I'm a Java architect and a codesmith, and I'm working for Soprasteria in the Netherlands. And I'm currently being contracted by the Dutch National Police. And this presentation partly originates with my journey over there, where they actually are using GraphQL. And, well, I had an opinion. And, well, we'll walk through it, and I'll show you where I hit my toes and whatever happened. But then again, I'm here with Peter.
Yeah, I'm Peter Eijgermans. I'm also a codesmith and front-end architect. Works also for Soprasteria, and I work for the Dutch Railways, where we also work with GraphQL. But let's start with the game. Why GraphQL? Let's start with it. We have now here this application I've created. Here it is a beautiful DJ application where we can, okay, hear some music.
So are you still awake?
Yes.
Because today is about the party. So this presentation, it's all to keep you awake and get you awake, and it's about the party.
It's about party, yeah. So you see a lot of data here. We've fetched some a lot of songs and tracks here where you can select. You can also react on the atmosphere in the crowd when the energy drops, or when the dance floor has to fill up. You can also do some requests from the audience and some recovery. So, okay, let's go further with the slides.
Yep.
So we have here a context diagram. It shows the system at high level, of course. It's a very simple diagram. Front end is Angular and Apollo we used in the client, and in the Spring GraphQL is our backend.
Surprise!
Surprise! This is the single API entry point for our application, and the backend is driven by the GraphQL schema. That is our contract. That is really you can say our API between the front end and the backend. And also it is driven by, the backend is driven by the resolvers. Those are mappings, operations to code. And also we have services and repositories in the backend. And how does the data flows? The data flows from the front end, sends queries, mutations via HTTP to the GraphQL, via GraphQL to the backend, and the backend receives subscriptions as live updates over GraphQL WebSockets. And the backend resolves requests using schema and resolvers. We see, in short, the UI asks exactly what it needs. This is what GraphQL, the strength of GraphQL, and the backend enforces one type of API contract. And live updates keep the screens in sync. So let's go further. The why. Okay, today's journey we're talking about the what, the why, and the how. And the why we start where the rest, where does the rest stop scaling for us? And where helps GraphQL us with solving. And also the what, about the main model, how it is set up. And how does it work, and how does it wires together with Spring, and also the how do we, how do Angular build? We've built micro-frontends with Angular, and how do we consume those data in the front end with micro-frontends? If anybody work with micro-frontends? Or yes, you?
One? Okay, good.
And on the other end, GraphQL is we've worked with GraphQL already.
Okay, really good.
Okay, nice.
Then we'll have something. We'll actually have a lot of ground to cover. So maybe we should speed up a bit, because otherwise we're going to be right out of time.
Trade-offs and the decision criteria at the end. And so REST still works, that is in some cases, and also it doesn't. So where does it work? We have one consumer or one simple application. It is always good to use REST, and there is also a lot of good tooling. You know them all already, OpenAPI, Swagger, and HTTP caching is also out of the box with REST in the GraphQL. That gives, it's quite difficult to solve that, but okay, it is doable. But and every team, knows how it works with REST.
Just to be sure, everyone work with the Spring Web MVC? 1, 2, few hands? 4, 5? Goodness, thank heaven. Okay, good.
Where it broke down, for us, the DJ screen needs a lot of data, sessions, tracks, songs, and artists, and we can solve it with one fat endpoint, REST endpoint, but that is not what we want. We want to also use live data, and then when we use REST, we have to pull the data every time. We don't want to do that, so we use subscriptions. So the data is pushed. Okay, let's go.
Yeah, let's go.
Let's go. Here you see an endpoint, a get endpoint.
So this is basically the REST tags, the thing that hampers us in our application if we would do it like this.
Like this, you see that this endpoint delivers us loads of data. It's too much. When you have a small front end, you don't want all those data.
And at the end, you see this timeline, and of course, the timeline grows and grows and grows and grows and grows, and every time the response will be larger. So bad idea.
Bad idea. Yeah. You can also do some events.
And if all goes well,
also,
that ends well.
Yeah. And then you see it growing, I think.
Yep.
You see it, yeah.
Like more.
Okay, more and more.
Bad idea, just don't do it.
Yeah. What if the client could ask what it needs? So not via URL, but via query. We can ask what we want in the front end, and the client declares exactly what it needs, and the server answers precisely what we want. And the same, we can use the same endpoint in the same schema, the same API, and we can also query what we want in the front end. And how do we do that? Here we see an example of a query, the current mix session, and we map here to a current mix session field, and it contains an ID and also all those tracks and all these data we need for our DJ app. And we have also another query we can also make on this same field, the current mix session field, and it only returns one track, the last track, and the song with the title and artist, but it does not contain the audio file. So it's quite flexible to work with GraphQL. Yes.
Here you've got this audio file, and there it is. And basically, as a client, when you ask the server, you can ask, "Oh, okay, this time I do not need the audio file, so just skip it, right?"
Yeah. So you skip what you want or add what you want. And here in Angular, in the front end, you see how you use it. We use also Apollo as dependency, and we can, quite easily, we can grab the data via the apollo.query, and then, in this case, we want to have the audio session data. Okay.
This is TypeScript. You know, everyone familiar with TypeScript? Yeah. Okay. Good. One more. Okay. Good.
Like what I already said, the schema is a contract. That is the API. That is contract between the front end and the back end. And schema is defined in SDL. SDL is
the schema definition
language. We can define it before we implemented this something. Of course, it's our contract, and the query is public API service. You see a type query, how we define it. And also the field current mix session, what we showed already. We can and also it contains a mix session and also enum we can define here. So this is in a nutshell the beginning of our talk. The party. Okay.
Let's just get started, right? Yeah. Because what's a party about? Everyone been to a party? Oh, it's so late. Goodness. Yesterday, are you still awake? Good. Okay, because a party, you know, there's this venue and a lot of people there, and what do they come from? To dance, right? And what does a DJ do? He plays his songs to get everyone to the dance floor. So just don't come up everyone to the front, because it's going to get like really crowded here. And what the crowd does, the crowd can react like, yay! Or silence. Or they can send audio requests, like, hey, I want to play this song, please, right? And then DJ, what does a DJ do? Well, actually, he prepares his session, right? So he has his own track library that he can play. And from the track library, he selects like the tracks that he thinks in advance that'll be useful for this specific party, right? So during the party, he selects tracks that, and he can add tracks by reacting to the crowd and to keep the energy up. I want music, DJ. Yes. So this is the app. Let's get a lot of music, because we want to keep you awake. Not sure if it works? It works. Shoot. Yeah, okay, good. Let's get going. So, we have this Spring application, and the URL for the GitHub repo I'll post up at the end, so you can all look at it. There's also the Angular and the presentation is there too, so no need to take any photos or whatever. So, I'm technically a Java architect, and I love domain-driven design. Anyone love domain-driven design or hexagonal architecture? Good? Good? Good. Excellent. Love it. So we have the music library, and the music library is basically the static library that the DJ has. And the session track is derived from it at runtime. And that is basically the session that is evolving during the party, right? So what does that look like? Well, it's also got a domain model. So we have, oh, it's a bit small, isn't it? Can anyone read it? It's really, really small. So, okay, I'll just walk you through it. So we have like the crowd events. We have the disc jockey. We have songs. Well, you have soundtracks. There are also cue points. A cue point is basically something that, actually that is part of the music library. So a song has a certain, the DJ, I've heard this from a colleague of mine who's actually a DJ, so he knows I'm not, that's why I'm a bit womp. Okay, so a song, he partitions it sort of, and says, oh, okay, if I start at that specific point, then that really helps get like the audience up. And at the same time, so that's the way he reacts and prepares his session. And well, there's also songs and artists, of course. So we have the session model, and the mix session now is the aggregate root. Basically, the aggregate root is the, in terms of domain model, is that where you ask the question. So give me whatever something, I need to do something on my mix session. I've got like an audience request, right? Or play. And now let's get to the schema definition language. And we've seen like the domain model, well, although it was small, hopefully you get the idea. So we have like the mix section, we have session tracks, we have songs, and all of them have properties, right? So a song has properties, has like a title, an audio file, and an artist who's playing it. And the client declares what he wants. So continuously we have like this double argument, right? So the server, on the server side, we know what we have. We have like everything, and the client says, oh, okay, this time around, I only need this, please. So that's basically the general idea, one of the differences with REST. Mm-hmm. So how does this actually work in Spring? Because we're here for Spring, right? Spring GraphQL, the schema, resolvers, the mechanics. First, just a few wiring points. So a Spring MVC, the standard REST controller, he has like, you have like this class, the controller class, and there's all sorts of get mappings and whatever mappings, not only get mappings, of course, but you have the mapping per URL, and on the other hand, we have like the Spring GraphQL, and there's only one controller, and the query mapping, there's like quite a load of them, and I'll show you what they look like, and what's good about them, and what's good about them, right? So we have the routing. So the routing on MVC is based on the URL and the method, which can be like post, put, get, patch, whatever. And on the other hand, we have like the schema field name, and that maps straight to the method name by convention. You can override, but, well, I've never done that. I've never seen the use for it. So there's field resolution. So on the left-hand side, the controller always returns like this huge big JSON file, or could also be, anyone still using XML? Good. Heaven.
Nobody.
Thank you. Okay, so on the other hand, we have like the schema mapping, and that's where that's basically the server-side mapping of the way that the client can select whatever it needs. The client shape on no, it's server fixed, and on the other hand, we have like this. So basically, the tracks and last.int. I'll show you that in a minute how that works. So basically, you can restrict what you want, not only by saying, oh, I don't actually need the author. I can also say, instead of all the tracks of the current session, just give me like the last 5 or the last 1 only, right? So you can, as a client, you can restrict in any way you want. And I think that's actually really cool if you do it right. And that's one of the things that I found weird at the Dutch National Police, where they actually don't do it. Say, hey, okay, you have this fantastic tooling. The idea was right because they have like this, we have like this front end, they have them too. They have like 5 different tiles, and the users can select different tiles, and depending on that, they could have updated and changed the query to say, okay, for this micro-frontend, I only need this, but they keep asking like the whole lot every time. And then basically the idea is, you lose your advantage. So I've got like a battle to pick there. You get the idea? Yeah, I know. So we have the request chain on this is actually how it's implemented, and maybe the most interesting bit is, so we have like we post like always to /GraphQL, the query, then the execution GraphQL service is a Spring framework thingy. The query mapping is that is what we code ourselves. Then the controller applies the domain event. It sends back an updated aggregate if there is a mutation. Otherwise, there's no aggregate updated, of course. And the resolved value is sent back as a part of a JSON response within the data field. So let's have a look how this actually works, and let's see some code because it's like really nice. So basically we have like, this is the implementation of this Docker GraphQL controller, and we have it in IntelliJ as well. So let's switch to that. So DJ controller. And what you see here is, let's just go to all the top. Okay, so here we have like is this actually readable for anyone in the back? So I thought so. Let's just make this a bit bigger.
Okay, nice. Yeah.
Yep, okay, good. Better? Okay, good. So we have like, as you can see, this is like Spring, right? Anyone know Spring here? I expected like all the hands up. Come on, wake up. So we have like the query mapping. So this is like the current mix session, and we can go straight to the GraphQL schema, and this is our actual schema. So it's actually not so large. We have like a couple of types, right? So here's the mix session, and here's the track, and this is the parameter, the argument that you can give, right? So let's get back. So here are the mutations. These are the queries. And this is the entire scheme.
Okay, the current mix section maps with the other one.
Yeah. Okay, so let's go to the GraphQL controller. So we have like the current mix session, and basically all what it does is like this. So the session, so if you give me the current session, and what that one does is, so let's go to the implementation, of course. So find current or else throw, give me an exception if the idea is unknown. So if we don't have the idea of the current, there's no, so this is find current. Oh goodness. Right, so find current. Well, find all stream, reduce, whatever, or something. Give me the... Okay, and on the other hand, we have like the get session by idea. Hey, gosh, it's a repository.find by ID or else throw mix session not found, right? So, and the same with track, we can... where's that? We'll just... let's just go to the presentation back. That doesn't work like that. So this works. So we have like the current mix session. So these are the codes. Let's do it and see what happens. So loading with like good mix session idea, right? And paste it. And oh, this is something. Oh goodness. I know what happened. I guess I pasted the wrong idea. Good, excellent. Is this actually readable in the back? Right, so here's like the data thingy, and there's the mix session, and the mix session gives like tracks. These are the tracks that have been currently being played. And I can also do like something different. Hold on for a sec. This presentation, I still have to get used to Reveal.js. Sorry about that. So I can ask, get the mix session by, oh, that was that one actually. Haha, good. The other one, I wanted to paste like the current mix session, so this should work. And then, okay, good, paste, yes, good. So here we have like the current mix session, and this like returns all the tracks in the current session. So that's the way you can like query and how it works for queries. So next we also have mutation, because hey, what's life without what's a database without something that ever changes? So crowd cheers, right? Mix session service apply crowd cheer. We'll have a look at that because that's like a bit more difficult because there's a publisher in it with a subscription too. So we'll come back to that one in a sec. So the mutation mapping for request from audience. So basically what this one needs is the idea, the ID of the session and the track name that it has been requested, and it calls apply a request from audience to the mix session. So let's have a look at how that what that looks like, because it's like sort of similar. So it's in the IntelliJ, go. Yep, okay. This is the wrong class. Let's get to the controller thingy. Sorry. Request from audience. So we here where we just had like query mappings, now we have like add mutation mapping, logging. What else is it then? Just Spring, right? So wire it up. We have the mix session service, apply the request from audience, and return the updated session. Let's just take a quick look what that thing does. Basically, it's a transactional method, and it has this idea, and it says apply and publish because there's something going back. And actually, this one also does apply and publish, right? Because apply and publish is always, we have like this client, which Peter built, and that wants to be updated on what happened in the front end, right? So let's get to that in a minute. How fast can you do this? So next thing that is like really interesting is the way resolving of the fields actually work. So you have to code it, and this is the way. The tracks, so that is the where the as I showed you, you can like give me the tracks, the last 5 or the last 1 track, right? And this is how it works. So this parameter, this last is just an argument, and it can be null. So if you don't specify it, then it's just like mix session.tracks, and if it's null, or we ask too many, then just return the entire list, and otherwise I want to return the sublist with only the last 1 or 5 or the last whatever, right? So how does this actually wire in Spring GraphQL? It's all in the same schema GraphQL. So we had like the query, we have the mutation, here are the subscription. So that's when the session is updated and when the crowd tally is updated. And Peter will tell you more about that. But the thing that I wanted to look like was like this one. So the mix session, right? So tracks last. And here you see here like the mechanic thing. And here we go to the schema mapping, which is incidentally also in the GraphQL controller because we put everything in one class, because why not? Then at least your class becomes like, well, a lot of lines, but not so many. So here we have, so this is basically how you wire it up on the server side, right? At least for queries and mutations. And now let's make it difficult. Oh, errors. Oh, interesting. We already accidentally saw the error that happened when I asked it to give me the session of an idea that does not exist, and it was not in the console ID, it was like in here. So This is what returns when you get the session, when you ask the session of an idea that does exist, and when you get one that doesn't exist, then you get here like the errors. Does anyone know what you usually do on REST? Like HTTP error codes, exactly, return codes. In GraphQL, you always return 200 usually, and you put the errors just in the as a JSON object. And
It
say,
always returns 200, you say?
Yeah,
Okay.
As a rule, yeah.
HTTP 200, always. Okay.
Yeah. And there's no data this time. You could have, but and how is that wired? Well, it's in the error, not that one actually. Let me go to the correct class. It's right next to it. Here's the exception resolver, which extends a Spring Framework class and resolve everything that happens into one single error. It says, oh, okay, if we have like a DJ console exceptions, put the error code in it. If you have like a mixed session exception, well, you can like gracefully handle the exceptions in the way you like, right? You could also return, say, oh, okay, actually, I can imagine you calling a backend service, right? Which we at the Dutch police do like loads and loads and loads of times, and just one of them doesn't answer or not in time. Then we can just aggregate whatever we have and spawn that back and just ignore whatever failure or give that to them. So unfortunately, we couldn't get this for you, but we could get the rest. So hopefully this at least helps you in resolving the crime. Thank you very much. This is actually something that I really like about GraphQL. Whoever does testing, unit testing, TDD,
okay.
Good, because this is. So at the Dutch National Police, we were also using like GraphQL Java, and that's basically the stack on which Spring GraphQL is built, right? So Spring GraphQL is an abstraction layer on top of COM GraphQL Java, and the Dutch National Police, they have built like their own wiring layer because, well, you can. But I really like the way this is like. So basically, your test should get current mix session. Given mix session service that current session will return a given session. Then document name execute gives me this, and of course we can run it. Oh, and also, are people loving Arc Unit? Anyone? Okay,
oh,
good,
nice.
good. Yeah. I'd like to see more hands for Arc Unit. Arc Unit is really, really good. If basically in this application, it keeps the GraphQL layer clean in the sense that, as you can see here, my service can no classes that reside in the service package can depend on controller, GraphQL, or whatever classes, right? So basically, this is the way that you can enforce with your tests that that you don't have like the wiring. Which is like horror, and I've seen it. Let me see how much time have you left. 20 minutes?
Yeah,
okay.
not so much.
Yeah. Test. So this is like the test, right? Let me just run one test and see that it works. Run. This is the should get current mix session, and it passes.
Wow.
Good.
Okay.
Let's get to the subscriptions, because that was the missing link, and I'll just skip this diagram because it's like, so basically what happens is the server says, oh, okay, something has happened, I need to push data, so it publishes the data, in this case the session, it's emitted, well, it uses Flux, and it filters the session ID so that a given client only gets like the updates of his or her session, and then that's basically what happens.
Okay, with WebSockets. Does anybody work with WebSockets or?
Good. More WebSockets. Okay. More hands for WebSockets. Not
so much.
Server sent events. Anyone for server sent events? Okay.
Okay.
Good.
Yeah.
That's also like really good. Let me just. Oh, sorry. Yeah, because I wanted to. The real-time server push, and hopefully this works. It usually does, but sometimes, well, it doesn't. So we have like this, let's just do this one first. So we have like, where we just had like query mapping, mutation mapping, we had like the schema resolve, and now we have the subscription mapping. And what it does is give it an idea, in this case the idea of the session that has been updated, the mix session that has been updated. It returns, hey, presto, a flux of the session. And we connect, well, Of course, this Flux has like only one, because there's only one session that has been updated, right? But you get the idea. You could like return more, and good. So it concats the current session to the Flux, and it streams it back. Good.
Are there questions until now? No?
Because
I hope quite clear, but...
Yeah, so this get session by idea. Why is this? Oh, this is the service mutation. Yeah, okay, exactly. That was what I wanted to show with the apply crowd event. Let's just do the demo first. Let me see. Hopefully this works. GraphQL. No. No, here, this one. Demo with GraphQL. Yep, okay. Hopefully, just give me the URL, because then I can put it in here. I hate this. Yeah, okay. These are the demo days. Okay, that's one. And here is the other one. Paste, more GraphQL, thank you. And then this is like the mix session updated. So let me see. I want to put this one over there, and then, so basically here we have like the stream. It should, I would expect it to not. We'll see if this is gonna work. I highly doubt it. Let's just kill the server just for a sec, because, hey, who notices? No. Is this actually, yeah. And this is the test, and that was actually not the one that I wanted to do. It did, no. Let's get the application running again. Yeah, okay, good. No, this one, play. Yeah, okay, so now it's running, right? Now it's like this, you can stop it, but it shouldn't be stopped. And now if we paste, right, so the crowd cheered event into it, into this one.
That's an event, okay.
This is the event, and if all goes well, that ends well, then the other one should be updated, right? As you see, it does, right?
Yeah.
So basically we get this service and push from, yeah. So.
Okay, right. Yeah.
And let's get back to the code. So that was this demo, and do we have time? We've got like time to...
go for it.
Yeah, okay, good. Let's go for it. So let's get to the imply crowd cheered event. Right, so we had like the mutation mapping. That was the one that I'm looking for. It's in the controller, and look for the apply crowd cheered. Okay, so we had like the crowd cheered event. This was the mutation that we just sent over, right? The mutation, crowd cheered event, right? With the idea of the session, we had like this, and the mutation apply crowd cheered event. And what does, yeah, okay, the implementation, null. So what does this do? As you can see, this is like a transactional. It gets a session by idea, it applies the event, and then it saves the repository and publishes the updated saved mix session, right? And what does this? Emit next, what else? What would you expect?
Okay, we'll publish to all the clients.
Yeah.
Okay, yeah.
Good. And I think that covers like the server side. A quick recap. So what do we have? We had like the schema definition. You put it in source, main, resources, whatever, in the GraphQL thingy. Then Spring GraphQL picks it up. We had like the query mapping and the mutation mapping, which sort of are the same as the get mapping and the post mapping and the put mapping and whatever in the on the Spring Web MVC side, right? So the internals, we had like the schema mapping. That was the way things actually work and are resolved. We had like our extended class of the data fetcher, whatever, something except adapter, and that's the one that actually does like the exception handling. We had like the GraphQL test, which is like amazing, combined with ArcUnit, and we have like slices that have been like decently tested. No cross-wiring of controllers and GraphQL and whatever things. So, and then the push layer, we had like the subscription map, we have the flux concat over WebSocket, and the servers calls the publish and never import a GraphQL class because we hate it. Just don't do it. And now it's Peter's time for my best friend.
That's a lot of information. So we know a little bit of front end now. It's more lightweight now. In the beginning, we are talking about Angular and also a little bit BFF solution. Have you heard of BFF, backend for front-end solution? Yeah, okay.
Good.
Very good. For the front-end, we use the micro-frontend architecture. You see here how it is made up. First, in the micro-front architecture, always there is a host application. And the host application is responsible for routing and also authentication, authorization, and also for which micro-frontend underneath are loaded on the screen or rendered on the screen. And in this application, we have two remote applications, two micro-frontends. They are called remotes. And the advantage of micro-frontend architecture is that Team A or Team B or Team C, which is working on the host, they can build their application independently. So this is what you want, of course. It's the same as with microservices. You want to build your application independently, so it's on the front end the same, of course. And this, what is good about this is that you can load this application at runtime and also stitch it together at runtime. So, and they all use the same schema, and all use the same GraphQL contract. In our application, we've set it up in this way. For the host application, that is our DJ application, and underneath we have also, I haven't shown it already, not yet. I have also a vote application where you can vote some music with a QR code, and also another front end with some information on it, so only for the demo. And yeah, this is the setup a little bit, and the Spring Graph is running on 8080. So yeah, and now we are using module federation. So have you heard of module federation for the front end, for micro front ends? It's very good stuff because you can easily load these micro front ends together, but you can also load in this. We use Angular. Angular will load it one time. So for when you have 100 micro front ends in your application, it will not load it 100 times, but one time it will load Angular or your other shared libraries. So take a look at model federation. In this part, we use native federation, which is much better. But okay, we can start with model federation. And yeah, what do I want to say about it more? We have we have not so much minutes anymore. Okay, the BFF strategy is what we have here. For example, a web application which needs all those fields what we want, and then we can have a mobile application which want to show only the status or some fields, or a dashboard with some other parts. And in the middle we have the BFF, which routes all those maps the fields to the right service underneath. We've seen it already in the talk. So this is our BFF solution. Okay, the demo payoffs. Let's go further. We have not so much minutes anymore. Here you see from the front-end view, you see the same flow a little bit what we have explained already. The above part we explained here. The query. We do a query for the critical user journey I show you for the DJ console, of course, and we do. At bootstrapping of the application, we query the current session, and then we show the current session with all the songs, of course, and then we also do a subscription. We set it up for events, and also in the end, we can also do some mutations from the front end, of course, and the mutations also results in events, and it will be published to front ends. Okay, let's go and do some music. Let's imagine the audience.
Something went wrong.
Yes,
and
we were dancing, and somebody. Oh, it's not working at all. We were dancing, and somebody wants to do a request of a.
This is actually, according to my colleague, something that really happens. Like he makes a mistake, and suddenly everyone just walks away from the dance floor. It's like, oh, horror!
Yeah, that's not what we want. So we recover, of course. That is not. Not a big deal, of course, but okay.
Yeah, for him it is.
Yeah, it is. Okay.
So basically the idea is, when that happens, he said, I have to play like a track at the peak level to make sure that everyone comes back to the dance floor and thinks, oh, okay, oh, this was just like 1 second horrendous moment.
Let's say that we recover it. Okay, firstly we do a setup, how it works, a little bit in code. So you do a request from the audience. We apply a request, and then we do a apply event. And on the other hand, we have also the apply recovery from the DJ, and he has also his own event to recover it. So it is all the same structure, so it's not so big, so not so difficult. Okay, this is what we use, of course, for we've talked about it already, the current mix session. And also the apply recovery of his own mutation query. Let's go to the crowd vote first. We've created also I was talking about micro-frontend, so we have a micro-frontend with some a REST endpoint where I show you. I have also another micro-frontend, which is where we can vote some data, some music. So I suggest you can.
Can you check?
Which one?
This actually should work.
Yeah.
But then, so from the internet, you go to my laptop, and then it goes, it routes through the Angular application, right?
Yeah.
And then to the backend, and
we can show it.
Actually, so the crowd vote should look at that.
Okay, everybody's voting the same. Okay, that's
Can anyone vote for Chrome Thunder? Yeah, good.
Okay, this is really a little bit about how it works with subscriptions and real-time data. So,
as you can see, this really works.
Yeah.
It should play into 1 second. No.
Is the music on? No, not yet.
Yeah, you have to play the winning track.
Yeah, play it. Push.
That's the one.
Okay, right. Okay, thank you for this part. Help. So this is the part of the code we use now for the audience scans the QR code, and we use there this mutation query for the crowd vote mutation, and it received the slot. I can also show it in the screen, of course. What was it? Yeah. Okay, later on.
There was like the 3 QR codes, and each one was a slot. Basically, that's the idea.
I show you later.
Yeah.
And also we have a dashboard for you saw it already, the crowd vote live, the dashboard.
With the bars?
With the bars. So this is the other one, and also the DJ applies the winner. So this is the third one.
That was the button?
Yeah. Let's see if I can.
Okay.
Let's see the URL.
Right.
Here you have QR codes. It ends with /slot0. So how does that map to the code? Can you
I can show you. Hopefully, if we've got time. So we start at in this. So this is Angular magic, and I'm not an Angular expert, but it goes into approutes.ts with like the vote, right? So this is the path. I'll try, and you correct, right? So we have like the crowd vote page component, and so
that will grab here from the query parameters. We grab the slot number, and then the application knows from that slot we have to.
This is pipe take map.
Here it will.
Yeah, okay, here it will go. And actually, where's the query? Oh, this Apollo mutate. Oh, yeah, and here are when we go to The queries, these are the queries, so these are the queries that the front end actually knows. So you can see quite a lot of them. So, and you, and the general idea is that every client, so now we've got like only the Apollo client with the dashboard, but if you have like a mobile phone, usually you would have like less on the screen, right? At least in the old days you did.
Let's just finish it. If,
yep.
You can go further.
Yep. So that is the way that crowd votes work, and the bars are updated via the WebSocket, and it's like, I think, well, Spring GraphQL, I think I really like it. So we want music, so let's wrap this up because we are out of time. So, question 1, should I migrate? Well, you never know, of course, but there are a couple of questions that you can ask that can help you guide towards REST or towards GraphQL. So if you need HTTP caching, that means you start in the middle. Just go for REST, right? Because GraphQL and caching, that's not a good idea, because you have like this post and it's a single endpoint, just don't do it, right? So if your team is only experienced with REST native and you don't have time to invest into GraphQL, just don't do it. Stick with GraphQL. On the other hand, if you have like a lot of different consumers and which have different needs, and also depending on the use case, so we at the Dutch National Police we actually have like loads of mobile apps for different policemen on the street and also the investigation crew, and they all have like different needs. So that would be like a really good use case if, like, and etc. etc. So should I migrate, lean towards REST, or lean towards GraphQL? The API shape, we've seen that one. Versioning is something very important. Who loves versioning with REST? I don't. I hate it because it's always breaking things. And on the other hand, you have like GraphQL, and it has additive by default, and you can deprecate fields and say, okay, this one will be gone in like some time, and then you give your clients to gracefully time to degrade and gracefully time to upgrade, whatever. So the error model in HTTP, you have in GraphQL, you have like the HTTP 200 as we showed. The tooling maturity for REST is like excellent with OpenAPI and Swagger, and we have like the schema introspection. I haven't showed you, but in both in GraphQL and in Spring, you can enable introspection, and then you can just see what the schema is that is exposed. Over and under fetching, that's basically the problem that you usually have with the REST, where you like get like this big responses, and it gets a response whatever you don't need. And on the other hand, you have GraphQL, where it's not necessary, right? It works. First, it survives production. Anyone goes with the application to production? No one? Oh, good. Thank heaven. So, there's a lot of things. This demo application, it's not hard and whatever. There's no Spring security in it, but you can put it in there, and it's just like, it's Spring, you've seen it, right? So this just works. The difficult bit is, once again, subscriptions. And a lot of things, pagination, you can also enforce that with GraphQL. I haven't showed it with scrolls and windows and all these nice things. Security. Does anyone like security? Good. More hands. You should have really. Everyone should stick up their hands with security. Security is like important, and you can also. So for the Dutch, I also have this for other government clients. So the same person, depending on the role he's currently using, can have different authorizations. So when I am as a forensic officer, I may see more or different things than as a regular person at the office, right? So the same person can have different authorizations. You can all do that in GraphQL, right? So pre-authorized, it's Spring, right? And subscriptions, well, it's like difficult, you skip it. So in the end, what else is new? Use the right tool. REST isn't wrong. GraphQL isn't magic. The question is, who are my consumers? And can they live with what I give them today? And if the answer is no, that's the problem. And maybe GraphQL can help you solve it. Here are the links, and we can put them back on. Any questions? We've got like a couple of seconds. Maybe after the session, you're all there. So thank you so much.
Okay, thank you.